Hi, I'm Yiqiao Chen. I'm a PhD in land economy from University of Cambridge. I'm going to present an ongoing project today, which is understanding the representative 24 hours travel activity sequence of Londoners. So I'll first introduce the concepts and then give a little bit of literature reviews, then introduce my case and the data set that I used for this study. I will also talk about the methodology and the results for now. And then I will discuss about the future directions and to briefly sum up my study. The first one is the concept. The travel activity sequence is a traveler's time use activity in a time period. And the sequence could illustrate the information such as locations, functions, purpose, and the modes in each time interval. And different kinds of sequence can show various information. For example, a commuter who live in Cambridge and then work in London would have a location sequence like this. So from Cambridge to London and then come back home. And his trip purpose would look like home, work, home. And then we can also extract the mode sequence, which will look like, for example, he took a train to work and then drive back home. And different informations, sorry, can be integrated together into a more complete sequence. For example, the trip and purpose sequence could be integrated together and it would look like that. And in this study, I will use the sequence that looks like the last ones, that is 24 hours activity sequence. It could be understood as a daily sequence or episodes that is in the form of a sequence of 24 letters, and it represents activity states, for example, home, in each hours. And why do we need to understand the 24 hours travel activity sequence? First, it could reveal the travel patterns in the city. And then, sorry, we could uncover the travel behavior of the citizens, then to increase the accuracy of relevant models like activity-based travel forecasting model. So this study intends to first identify the representative 24 hours travel activity sequence, and then to review the dynamics of change in the travel patterns yearly. And the last two objectives is still ongoing. So I will only present the results of the first two objectives in this presentation. Then after we find the travel patterns in each years and the representative activities, we will also quantify the influence of different social demographic variables, link each clusters to the social demographic factors. Then try to predict the travel sequence of different social demographic groups. So in terms of the literature, there are several data sources that are used a lot in relevant studies. First, that is the travel survey, and then time use survey. Also, in recent years, GPS trajectory from either survey or mobile phone are used a lot. And then the smart card data, especially the Oyster card data, has been used a lot in the London case, but it mainly reveals the travel patterns or travel behaviors from the public transport users. In terms of case studies, they are considerable varieties in case study by location. So it could be like as small as a campus in a university to a city level like that, like the previous study in Seoul or Chicago. Then it could be also a whole country like that in German or Canada. So they're at different spatial scales and focus on different subgroups. By seeing subgroups, public transport users are analyzed a lot, especially in London. And then previous research usually explore the regularity patterns and the mode choice behaviors. And this study, I want to explore the daily travel activity sequence of all the population groups not just the one who use public transport, but also private transport and active modes in the weekdays in London. So the hot topics in relevant studies contains classification of travel activity patterns and to identify the representative sequence and also try to find the characteristics of different clusters. And the main methods include sequence alignment methods, which is a method that from biology, and it was originally used to analyze DNA or RNA sequence, try to measure the distance between two sequence through calculating the minimal cost to transform one into another. Then for cluster and classification, there are several methods like hierarchy clustering, k-means, and also more advanced machine learning, natural language processing. But most of the study use hybrid approach, and these studies will use hybrid approach as well. So my case study is in Greater London. Is the capital of the UK, and 8.9 million people living and working across 32 boroughs within the boundary of Greater London. And the data that I use in this study is the UK National Travel Survey. It's a reliable data source, and it has been widely used to analyze travel patterns and inform policymaking. It provides a representative sample of householders based on a stratified random probability sample. So we use the sample of National Travel Survey to understand different groups of travelers in London. We choose the trips from 2012 to 2019. And we restrict the trips that both origins and destinations are within Greater London. And we also limit the trips that happened on weekdays. So the methodology contains 5 steps. The first step is to process the data, to clean the data, reorganize it first, and then to extract the temporal patterns and to build the 24 hours activity sequence. Then second part, I will conduct the sequence analysis. I'll first calculate the distance among sequence and then try to cluster and classify them. Then I will link the clusters to social demographic attributes. Then based on the results, I like to build a predictive models, and the results could probably further provide insights to policymaking, such as to find the target groups of like London night tubes. So the data in National Travel Surveys is trip-based. So we first reorganize it into individual trips in one day by the stage numbers that is coded in the data set. And originally, there are 23 trip purpose in numerous form, and we recoded into 8 activity types in the string forms. And the 8th activity is home, work, education, shopping, personal trips, recreation, escort, and the others. So then we construct our daily sequence in the form of 24 letters, which looks similar like this. A total of 52,886 daily sequence are extracted. So among this sequence, there are 8,953 unique sequence. They are generated from 16,704 individuals. And the top 5 sequence can be seen here. 2,613 individuals conduct the home education home trips. So they go to school from 8 a.m. and then come back home at 4 p.m. In the afternoon. And mostly seen trip chains are home work home, home recreation home, home shopping home, and home education homes. Then after building the sequence, I try to identify the representative sequence. So I combined two methods to measure the dissimilarity between the sequence. The first one, I use sequence alignment that can reveal the difference in both orders, activity types, and then to also add the informations of this difference in agenda. For example, whether people go to work or whether people go to shops, the different activity types. I also add agenda dissimilarities in the weighted sum distance. And the weight is from previous literatures. And I use edit distance, which is a very common seen algorithm in natural language processing, and are widely used to measure the sequence alignment. So it tried to evaluate the minimum cost of single character axis by insert or delete or subsidize one letters and then to transform the sequence from one into another. And then for the agenda dissimilarity, so it can compare the difference in activity types. So it measures the size of the intersections of those activities and divided by the size of the union of all the samples, all the activities. Then I use a three-stage clustering algorithms. So we first use affinity propagation algorithms to initiate the cluster numbers and to locate the initial centrals. This is a very fast clustering techniques, and it can show us the number of clusters. Then we use these numbers to conduct more time-consuming algorithms. So the second step, I use the K-Meadows algorithms to cluster sample sets of all sequence from 2012 to 2019 to identify the representative sequence. And this sequence are setting as the reference episodes. Also, this K-Meadows algorithm is run to cluster the data from each year, the full set of the data from each year. And finally, we calculate the pairwise distance between each sequence in the full set from the previous 7 years. We compare them with the reference episodes and to final classify all the sequence into different clusters. So this is an overview of the sequence. We can see that there's a huge group of the gray one is workers. So this is the workers group, and this is education groups. And there are several others that is in the chaos in this figure. And we reorganize it to distribute different activities. We can see this is the workers group, and this one is the recreation groups, also counts a great proportion. And then this is the students group. We identify 16 unique clusters from travel activity sequence from 2012 to 2019. So that includes 5 workers group and 11 non-workers group. So these are the 5 workers group that contains long hour workers, morning workers, daytime workers, afternoon workers, and night workers. And this is the students cluster. And here are the non-clusters group. So this one is the stay-at-home cluster that basically contains the individuals spend most of their time at home. And then the rest 9 clusters are night recreation non-workers, midday recreation non-workers, afternoon recreation non-workers, all day recreation non-workers, midnight recreation non-workers, and the rest 4 is midday shopping non-workers, midday personal business non-workers, morning escort non-workers, and afternoon escort non-workers. And after that, we also reviewed the dynamic of change in the travel patterns yearly. So this contains the representative patterns from 2012 to 2019. The number of clusters varies from 10 to 13 in each year. And we can see that in previous years, most of Londoners spend their times at home, work, and recreation. Activities usually took place in the daytime, and the main activities that happened at nighttime is working. The most stable clusters in the previous years are students and stay-at-home non-workers. There we can see changes in the number of working and recreation groups in each year. But the reasons for these changes need further explanations, which leads to my further direction. I need to find the social demographic characteristics of different cohorts with similar activity patterns, and then try to explain the yearly change through these social demographic variables. Also, based on these results, I think I can try to predict the 24-hour activity sequence of different population groups. And for example, like machine learning methods or the statistic models would look something like that. But there's a limitation in this study because of the data set didn't provide more finer spatial information. So the three very important components to build activity-based model. First, we need to know what type of activities travelers are conducting and the sequencing orders. And we need to know the start time, the end time, and how long does it take. But we also need to know their spatial information, which is not showed in the National Travel Survey. It just showed whether it's in central London, inner London, or outer London. So the spatial is not finer enough to conduct more detailed analysis. So if I want to add the information of locations, I probably need to use the similar methods to conduct studies, but use London Travel Demand Surveys, something like that. And to briefly sum up, so in this study, I talk about the 24 hours activity sequence, which contain a traveler's time use activity in a day, containing information like location functions, purpose, and trip modes. Different informations can be integrated together to provide a more complete trip sequence. And it can reveal travel patterns in a city. It can uncover travel behaviors of the citizens, and it can further increase the accuracy of activity-based travel forecasting models. And I mentioned a three-stage clustering algorithms to find a representative sequence. And we identified 16 clusters of sequence from 2012 to 2019, which contains 5 for workers and 11 for non-workers. And we also present yearly change in representative sequence, but we need further studies to explain the changes, and also further directions point to like building predictive models and add spatial information, something like that. So these are some key references. Thank you.
Thank you very much.
Any questions?
Thank you very much, Xiao. That was a very interesting presentation and perfectly timed. So thank you for that. We've already got one question coming in on the Q&A. So how do you define the number of clusters, and why 5 for workers and 11 for non-workers? How can you validate the findings of these patterns?
Okay, so the first question is how to find the number of clusters. That's why I use this algorithm, affinity propagations. So that's an algorithm that can roughly tell you the numbers of the clusters. Then you can use it is used to initiate the cluster numbers. And then when you have that numbers, you can run further clustering algorithms. And what was the second question again?
How can you validate the findings of the patterns that you found?
So there are several studies in London, but using different data sets, for example, the smart card data. So that, and also I think previous study have analyzed the commuting patterns. Then in that case, for example, like the workers groups could more or less be validated by like comparing to relevant studies. And also I have mentioned that because I also applied for the data set from Transport for London, the London Travel Demand Surveys. And I can use similar methods to conduct an analysis of that data. And I think that the results from London Travel Demand Surveys and the results from National Travel Surveys could cross-validate each other. If the results like come similar. But if that's different, then I think I need further explanation of why the result is not the same.
Yeah, hopefully that answers that question. Certainly makes sense to me. There's another question in the chat. What use and or links do you see for this work in the advancement of other models and methods, such as gravity modeling in terms of analyzing multi-purpose trips?
I'm not that familiar with like gravity modeling, but I think that's more trip-based model, if that is right. And so for the sequence for what I'm conducting to do, I first want to analyze the travel patterns or travel behaviors. And then based on that, this results, if the predictive models work, it could be part of the activity-based models. I think that's like another type of model that is different from trip-based models. But they're both pros and cons for these two types of models, but that's like another huge topic.
Yeah,
I hope I answered some this question.
Yeah, hopefully that's answered Philip's question. If not, I'm sure you can come back to that in the chat if you likes. Just another question here. Are socio-demographic data associated with the National Travel Survey, just such as job types?
Yes, I think it includes the attributes in the information that links to individual or household. It has that variables, for example, like what type of jobs and what is the income range, something like that. But that's like the next steps that I want to do to link the social demographic attributes to all these clusters that I find.
It's a bit of an obvious question, I guess. What impact would COVID have on these travel patterns? So obviously to the survey for 2021 or 2020, the data is going to be quite different. What do you think that might look like?
I think, for example, like the stay at home cluster maybe be much larger, and also maybe less workers groups, and that's what I'm interested in as well. So I'm really looking forward when the new data released, and I want to see what is the representative sequence in 2020 and probably 2021. I bet it has like huge change, huge difference compared to those in previous years, and it would be very interesting results.
Yeah, just as someone who's not familiar with the National Travel Survey, how do they collect the data? Is the data collected over 12 months, or is it just on one day in the year?
I think it collects for several weeks, or at least 1 or 2 weeks. So different days. It's not just one day, and it's yearly collected from a sample of households, but I can't remember the details.